In this tutorial, I will show you how you can connect Strudel with TouchDesigner using OSC. Before we start, this tutorial will be divided in 3 parts. So the first part will be the visual network. The second part will be the Strudel installation, because you need to have Strudel on your local computer in order to use it with OSC. And then the third part will be the audio reactivity with the OSC. For the first part, I want to save some time because the network is almost the same as the network I made on my first tutorial. So I pre-made the network. So I will just zoom on it. And then you can pause the video and just copy all the components. Then after I will go with you with each parameters inside the component so we have the same end result. For the point generator, we will change the shape for circle and the distribution would be surface. In the transform, you can change the scale Y to 2. In the particle pop, we will create a new attribute. We will call it rot and it will be a float 3. For the max particle, we will bump it to the maximum for now, and then the birth rate would be 1000. We can change it later. Life expectancy would be 6. Life variance 0.7. Initial velocity y 0.1. And we will also add a keyboard in chop just to be able to initialize and reset our simulation. So we will have 2 keys. Drag the first key on initialize and the second key on start. In the math mix, we will add one operation, A divided by B. A will be age and B lifespan. The result will be life. We will also add a new one, A plus B, which will be rot plus P. In the transform, we will change the transform order to translate, scale, rotate. Rotate Y would be 0.5 and scale Y would be 0.999. This will create an inward rotation. For the noise, the period 3, no harmonics spread, and we will change the amplitude to 0 for now because we will make it audio reactive later. For the lookup texture, we will edit the ramp first. Go back to the particle pop and click on maximum particle, copy parameter. In the ramp, change the resolution X, paste reference on it, and then resolution Y would be 1. Actually, let's just copy and paste the ramp that we just changed. Okay, for the first lookup texture, we want to edit the point scale of the particle so they don't have the same size. We will just reference the top and change the lookup index attribute U to live. The output attribute scope would be point scale. In the second lookup attribute, we will do the same, just reference the top. Lookup index attribute U will also be live, and we will reference the color for the output. Now we need to close the particle pop loop. Just drag the null onto the particle pop and parm target particle update pop. In the copy, go to template, enable template rotate, template scale, and then afterwards go into template attribute, enable the use template point attribute, and select color. For the proximity, just put the maximum distance to 0.1 for now. We will change it later. And max line per point, just bump it to 10. and you can connect the null to the first input. Next, we will make the render network and the post-processing. Okay. We will grab two geo. A camera, a light, a render tab. We can change the resolution like 720 by 1280 and change the pixel format to 32-bit float. Let's grab a transform, a null. On the transform, change the alpha to 1 and come over background color enable. We can make the view active to see the visual that we have now. We will add next a font material, form it with both of them. We will reduce the diffuse to 0.2 and increase the specular to 1. Okay, for the post-processing, let's grab a feedback. A level. A composite. Drag the composite onto the feedback. And let's change the operation to add. The level, we will change the opacity to 0.6. After that, let's put a bloom. Reduce the pre-back level to 0 and the min bloom radius also to 0. After the transform, we will put a level. That is our complete network. For the visual, I will just go do some tweaking so it looks a bit better. I will increase the particle birth rate to 5000. Just be aware that the more particle you have, the more it would be hard on your GPU. I will just tweak a little bit the point scale and the color. Something like that. Maybe make it a little bit bigger. We will now get to the Strudel part. Normally you can use Strudel on your web browser, but if you want to use OSC communication, you need to have Strudel on your local machine, because the way OSC work is that Strudel will send bits of data through channel or port, and it cannot be done on the web version. You will need to go to this website, which contains the Strudel code. If you know how to clone a repo, you can go ahead and do it. For those that don't know, you have some prerequisites in order to make this work on your PC. You need to install Node.js and install PNPM. To download the code, you can just click on more operation here and download. Once it's downloaded and extracted, you will need to open it in a code editor. I use Visual Studio Code. If you go onto the README, you have the instruction to know how to run it locally. If you didn't install Node, you can install it now. When everything is installed, you can run dev server using pnpm dev. Once it's running, you can just follow the localhost link, and then you have it. Strudel is running on your local machine. After that, we need to start the OSC server. So just go back onto Visual Studio Code. You can open a new terminal, and you will use the command pnpm run OSC. When the server is started, you will see that it's sending to a port. Port that it's sending to for me is 57120, and this would be important to note because we will need to use it into TouchDesigner. Let's go back in TouchDesigner. We will grab OSC in chop, and then where is the network port, you will write the port that Strudel is sending to. I have an error because I have it running on another project. I will just close that down. In Strudel, in order to send the data through OSC, we have to use the .osc function. The only thing is that when we use the .osc function, since OSC do not send sound but bits of data, we do not hear any sound coming into the computer. My way of doing that is by duplicating the sounds, which is not ideal for now, because if you have a pretty big song, maybe it will be laggy or you will have other problems. Start the song. When we start the song, we can see in TouchDesigner that we have some data sending. Now for me, it was pretty difficult to make sense of which data is coming from which song, so that's why I decided to edit the Strudel code. It's optional, you don't have to do it, but I will show you what I did, so if you want to have the same, I will give you the code and you can just copy and paste in Strudel. Let's open Visual Studio Code. In the search, you can search for OSC trigger, and you have to open the OSC trigger function in the osc.mjs file. This is where the message are sent through the port, and we can see that the address is always sending dirt play, and I wanted to change that to have something more accurate to the sounds, and also I edited a bit what value are being sent to have more choice in what I can pick for my visual. You can just copy paste and then save. To make it work, you have to reload the Strudel page and then reset the channel. Then you will see the sounds name and then the data. To be able to hear the sound in TouchDesigner, I found a way you can do it by downloading virtual VB cable. I will show you. So you can just download this software. Once it's downloaded, in TouchDesigner you can grab a device, an audio device in, and an audio device out. To hear it in TouchDesigner, you have to change your input of your computer sound. Your setting, you have to select the cable input, and then in the audio device in, you have to select the device would be the cable output, and in the audio device out, you have to select your headphones or any device that you are using currently. If I start the Strudel song again, then we can hear it. And actually, if you prefer, you could directly analyze this audio output if it's easier for you, but I want to show you how you can analyze the OSC data into your visual. For me, in the beginning, I was a bit confused on how I could use the OSC data since it's not a waveform, and it's easier to analyze sound with the waveform, so you can have like the low, the mid, and the high. My thinking behind this is I will use the changing values. I will start the song again. So we have the cycle, which could represent the kick of the song, and what I did is I used some sliders for the melody delay and also a high pass filter. So when I change it, then I could see that these values are changing. Then I could use these changing value to make my visual react. I will start by selecting the channel I want to use, and after that I will explain to you the math I did behind to use it in my network. Let's take a select chop. I will select the supersaw delay. the super saw MIDI note, the BD high pass filter, and the BD cycle. We will start with the delay. I want to use the normalized data of the delay, so I know that my delay goes from 0 to 0.4. In the math range, I will write from 0 to 0.4. I could have a range between 0 and 1, so it would be easier for me to use it in the visual network. I will add another math, and then I will add a null. I did the same for the MIDI note. And my MIDI note range goes from 40 to about 80. And I will add another math. I add another math because even though I have a normalized range from 0 to 1, I want to use another range after that. So I could, for example, change the amplitude of the noise or the bloom intensity and things like that. I will do the same with the high pass filter, which goes from 0 to 1200. For the cycle, I will use not a math but an expression chop, because now my cycle is counting up, but I want to have a value from counting from 0 to 1. In order to do that, I need to use an expression. The expression would be math.floor, then open bracket, me.input val times 4, close the bracket, and then we use the modulo 2. I start the song. We can see that it goes from 0 and 1. So add the null for now. And then there's another expression we can also use. If you want every cycle, so 0, 0 0.25, 0 0.5, 0 0.75, and 1. If you want like to divide it in 4 cycles, you can just use input.val and then modulo 1, start again. So this can also be useful values. Okay, now we are ready to plug our values into the network. What I did is I took the delay and I changed the noise amplitude. If I go into the noise and look up the amplitude, I can see that the more the amplitude is increasing, the more I lose the kind of effect. It's not really an effect that I like, but if you like, you can use higher values. But for me, I like more small values. Into the second math of the delay, I changed the range from 0.02 to 0.03, which is really a small change. And then you can just drag your value to the amplitude. And then if we start the song, you won't see much now because the values are a really small change, but if I change the slider, you can notice a bit of a change in the amplitude. For the MIDI note, what I did is I changed the seed of the noise. So let's do that. So the noise will move accordingly to the melody. I also wanted to add another element to that. So when the high pass filter is on, I also wanted the seed to react to this. What I did is I took the second math from the high pass filter and I plug it into the second mat of the MIDI node, and then I combine the chop with add. Let's press play. So it's a little bit more reactive. Next, I also used the high pass filter on the transform, and I did use it on the scale Z of the transform, and I wanted the transform to scale more when the high pass filter is on a higher value. So I want it to pass from 0 to 1 from 1.01, so it would like stretch more. In the second mat, actually I need to go in the first mat, and I need to change the 2 range here, because now the higher value is on the 1, so I need to put it 1 on the low end and 0 on the high end, and then go directly in the second mat, and on the low end I want 1.01, which will represent the higher value of the filter, and then 1 on the lower value of the filter. If we go in the transform and drag value, can play again. Let's bump up the slider. Another thing I did with the high pass filter is change the proximity line. I duplicated the 2 last component here, and I changed the second mat. I went from 0.1, which is the higher value, and 0.05. Then I went into the proximity and link it to the maximum distance. We can also make the bloom audio reactive. Let's take the second expression, connect it to a mat, and then let's say we want from 0.1 to 0.5, it to null. Then link it to the bloom intensity. Every time there's a kick drum, the bloom will be higher. The last thing I want to do is add the strobe effect with the kick drum also. We will take the first expression chop that we made, and we will connect it to the level. We will drag it onto the invert. So now every time there is a kick drum, we see that it's strobed from black to white, which is pretty cool. The only thing that I don't like is when I bump in the high pass filter, there's no kick drum, but it's still strobing, so we can fix that. Just need to connect the high pass filter with our kick drum. When the high pass filter is at high value, the value of the kick drum is always 0. We can add a mat after the expression chop, and then multiply it by -1. Then we will add another mat to connect 2 channels, that one. Then we will add the chop, and we need to add a limit chop, and clamp value, minimum value will be 0, and positive only. Okay, let's try that. It's working. We can view. That marks the end for today's tutorial. I hope you can take this and make some beautiful project. If you like this tutorial, please like and comment. I will really appreciate it. I will link all the project file in my Patreon, and yeah, see you in the next one.